All right, so let's do percent yield. The world is not a perfect place. All right? Whenever you do something, like how often do you get 100% on a test? Not very often. Just like you don't get, if you do a reaction and you put the exact amounts of everything in there, are you going to get the exact perfect amount that you calculate out? It's never going to happen. All right? Never going to happen. So, for that reason, we have something called percent yield. That tells us the percent of something that we make. Okay? So, to find percent yield, like how do I calculate what you get on a test? Percent you get on a test?
Oh my God, over what you're supposed to.
How do I calculate percent you get on a test?
Your score over the total.
So let's say that there were 34 possible points and that you got 27. So I would put points you get, the smaller number, right? Points that were possible on the bottom, and I'd multiply by 100%, right? And this would give me your grade on the test, right? In the same way, for chemistry, we ask, how much did you make? And if it went perfectly, how much could you make? Does that make sense? So this is how much you actually made. And this is going to be how much you could make in a perfect world with no loss. So, when we're doing this stoichiometry and predicting how much you could make, which one of those numbers are we always finding? When we're saying if I have this much of this thing, so let's look at this question. If I say that I react 5.95 grams of MnO2 and then I go through our whole process, what am I getting? And I'm trying to get grams of chlorine here, right? What is that number going to be? Is it going to be the top or the bottom?
The bottom.
It's going to be the bottom. Because I'm saying in a perfect world, if all this turned into chlorine, that's how much I'd get. But that's not going to really happen in the real world. So you'd also have to be given one more piece of information, which question 10 gives us. It actually, by the way, made 4.22 grams of chlorine. This is like in the real world, that's what it made. But in a perfect world, let's predict what it should have made so we can find our percentage. Okay, so in a perfect world, if we start with 5.95 grams, what do we put on the bottom here?
Grams of
Good, grams of MnO2. What goes on top? Moles of MnO2. Now what is the second step, the middle step always? Copy the bottom, and then what is going to be on top? There you go, moles of chlorine. And then what goes on the last step?
grams of chlorine.
What goes on top?
Grams.
So what do I do here? Numbers. MnO2, 86.94. To 1. Here, how many moles of MnO2? To how many moles of Cl2? They're not copying it. No? Look at your balanced reaction. It should be 2. No, it's good. It should be 1. It's correct. I'm going to doubt myself. Okay. And then, what do we put here? 1 and 70.9. So, how many grams would this make? This should make 4.85 grams of chlorine, but it made 4.22 grams of chlorine. How do I set this up to find a percentage? 4.22 grams, what I actually made, divided by 4.85, what I should have made in a real world, in a perfect world, times 100%. So, if we were to give the reaction a grade, what's the reaction's grade?
90.
87%. Should be about 87%. I'll say. Yeah. 87.0%.
Why don't you take into consideration the other CO2 that's on the right side of the equation?
Wait, this one?
Yeah.
Oh, because it's asking how many grams of Cl2 it
By itself.
made. This is manganese chloride. This is an ionic compound, right? So we don't deal with that. Because it's asking how much chlorine would come out of it by itself. Just chlorine. Yep, that was a good question. Okay, makes sense? Try 11.